Okay, Algebra 2, Unit 6, Lesson 13 is called Amplitude and Midline. So we're going to take a little bit of what we know about sine and cosine curves, and we're going to now translate them a little bit. Okay, so our learning goal for this lesson is I can transform the graph of a trigonometric function. I understand how amplitude relates to vertical stretches and how the midline relates to vertical translations. So the key words there are going to be amplitude and midline. Okay, those are new words. You probably don't know what those mean, but some of them you do, like vertical stretch. You should know what a vertical stretch is, and a vertical translation, you should know what that is. And then you should know what the graph of a basic trig function looks like. Y equals sine of x, y equals cosine of x, or you could use theta if you prefer. Most of the time, honestly, we've been using theta instead of x, and we've just been putting theta on the x-axis. Okay, theta is your angle on the unit circle. All right, so that's what we're going to do today. So you might ask, what is a midline? What is amplitude? Well, we'll get to that actually in a second. I thought it was on this slide. So, all right, so a little warm up here. We're going to talk a little bit about what we did earlier with parabolas. So we have stretches and translations and all that stuff. So we look here and we have our parent function is this one, y equals x squared. So, you know, if I wanted to, I could make a table here for y equals x squared. Okay, plug in some numbers. Okay, square it, so that'd be 4. Negative 1 squared would be 1. 0. So I'm plugging these x values into this function right there, 4x. Okay, so 0 squared, 1 squared, 2 squared. Whoops, 2 squared was 4. All right, make sure that these ones here are positive, because when you square a negative with parentheses, it's positive. Okay, that would really be negative 2 times negative 2, and everybody knows a negative times negative is positive. So yeah, so anyways, the one that looks about right would be, I think, B for 1. Okay, y equals x squared, because 2 is at 4. That looks like 2 4. 1 1 0 0 negative 1 1 negative 2 2. I'm sorry, negative 2 4. That looks pretty good right there. Okay, and you can see that those all match up. You know, if I look at 2 right here, 2 has a y coordinate of 4 right there, just like we have in our table, 2 4. Okay, so get rid of those. All right, so now the next one, number 2, if you remember, putting that 3 in the front is going to create a vertical stretch. Okay, I believe we had some rules here. We said f of x goes to a times f of x is going to be a vertical stretch if that number is greater than 1. Okay, so vertical stretch, this is from way back earlier in, I forget what lesson it was, what chapter. So if a is greater than 1, that's a vertical stretch. So the only one that's got the same vertex, because it's not translating, it's just stretching vertically, is going to be A. So this one here would be A. Now, if you wanted to make another table and just match the points up, you could. You know, we could do an XY table, plug negative 2 in, 3 times x squared like that, 3 times negative 2 squared. We're going to get 3 times 4. This will be 12. You can kind of see if I go left 2, I'm way up here at 12, which looks like my graph would go right through at 12 approximately if I were to continue up on my axis there. Okay, so you could make another table if you want, or you could use some info that we kind of already learned in previous chapters. So that one is going to be graph 2. So we've now matched up these ones. So for 3, it's going to have the same width as this graph. So obviously that one here is too wide. So I can narrow it down to D and E. And if you remember your rules from transformations, f of x goes to f of x minus a. That's going to be horizontal translation. Okay. And if it's always the opposite. So if it's minus 3, it's going to go right 3. So it's going to be, in this case, a units. It's the opposite. So if this one here for number 3 is x minus 1, that's going to go to the right one. So we want the same width as this. This one goes down 1 from the origin. This one over here goes right 1. Okay. So it's like you took that graph, y equals 3x squared, and moved right 1. And boom, there it is. So that would be y equals 3 times x minus 1 squared. So then that's pretty easy. We could say the fourth one is minus 1. So that's going to be, your other rule was, I'll write it right here, f of x goes to f of x plus a. That's my vertical translation. So since it's minus 1, it goes down 1. So this one here is y equals 3x squared minus 1 on the outside. And then the last one, this one here for C, C has the same width as B. If you look over here, I can show you there. See how they're the same width? So that's going to have no 3 in front of it. And that's just basically like I took this graph here, y equals x squared, and moved it down 1. And there it is. Okay, down 1. All right, so that one here would be y equals x squared minus 1. So I got them all matched up. A little review on translations and stretches. So this one here, I forgot to write, was vertical translation. Okay. Or not K, A units. The old book used to use K that we used to teach out of, but I think our book used A for everything. So, all right, on to the next. All right, so midline, amplitude, period. All right, let's start with period because this is not new. A period is one full cycle on the curve. So, distance between 2 consecutive maximum points or 2 consecutive minimum points, or really anywhere on the curve. But we learned on a sine or a cosine curve, y equals sine of theta, your period equals 2 pi. And then same thing on y equals cosine of theta. We learned your period is also 2 pi. So it takes, and that makes sense too, because on a full circle, it takes 2 pi, an angle of 2 pi to complete the full unit circle. After your angle travels 2 pi, you're going to repeat the whole unit circle. So when I plot the coordinate of the sine or the cosine on the y-axis and then the theta on the x-axis, okay, so this would be the x-axis is theta, and then the y-axis here is, if this is my y-axis, this would be a cosine curve because it goes starts at 1, basically, okay? Now, if it was starting right here, that would be a sine curve because it starts at 0, okay? And if you look on your unit circle, on your unit circle right here at the starting point, the cosine is 1 and the sine is 0. So if I'm going to graph y equals sine of theta, I start with 0, okay? Well, actually, no, that wouldn't be. Actually, that would actually have to be, whoops. Actually, I was in the wrong spot. That would actually have to be right there for a sine curve, because then you start at 0 and then at 90 degrees, you're up here at 1. So that would be the next spot right there at 1. And then we go back to 0 at pi. -1 at 3 pi over 2, and then we finish at 2 pi. So there's your full period. So that's review. Okay, I'm going to erase all that. All right, so amplitude. Now let's go to midline. Midline is the horizontal line that passes exactly in the middle between the graph's maximum and minimum points. So as of right now, we've kind of just, the midline has been the x-axis. Okay, so if this graph here is, y equals cosine theta. So let's graph this here. This graph is y equals cosine theta. Theta's on the x-axis. There's y. So y would be the cosine values on the unit circle. Okay, my midline is just y equals 0. Okay, but what's going to eventually happen today as we do this lesson here is we're going to shift our graph up or down or whatever. And what happens there is my midline now will shift with my translation. Okay, so if I move up, let's say, I don't know, say I go up 3 units here, my midline will now be y equals 3. And horizontal lines have y equals the number. Vertical lines have x equals the number. But that's what's going to happen there. Okay, so I'm going to get rid of that. All right, so the next thing is amplitude. Amplitude is the vertical distance between the midline and one of the extreme points. So if you look over here, we got this for amplitude. You could look at either one of them. One from the middle to the top, or the middle to the bottom, or the midline to the top, midline to the bottom. So we'll just look at the top there. It's that distance. So on a normal cosine graph, it goes up to 1 and it starts at 0. So your normal amplitude on a regular cosine graph is 1. Okay, amplitude's always positive. It's always absolute value. Technically, it's never negative. So on y equals cosine theta, our midline is y equals 0. And our amplitude is 1. Okay, amplitude, you don't need the y equals or anything like that. It's just a numerical value, but the midline is the equation of a line. So you will need to say y equals 0. You can't just say 0 for your midline. All right. All right, so we're back to the windmill situation here. So suppose a windmill has a radius of 1 meter. The center of the windmill is at 0, 0. So I'm going to go ahead and draw this right here. Put my axes here. Okay. So windmill has a radius of 1 meter. Okay. So I put a 1 there. Write a function describing the relationship between the height h of w and the angle of rotation theta. So the height is going to start at 0 right here. And then when I go pi over 2, I'm up to 1 for my height. And then when I get back over here to pi, I'm at 0. And then when I get here to 3 pi over 2, I'm at -1. So that's going to look like a sine curve. It's going to look like y equals sine of theta. Why? Because I start at 0. So if I were to plot the height on a graph here, okay, this is 1, this is -1, this is pi over 2, this would be pi, 3 pi over 2, and 2 pi. We start at 0, and then we go up to 1, back to 0, down to -1, back to 2. And obviously the windmill is going to keep going around and around and around, so your graph's going to continue to follow that pattern there, okay? But we'll just draw 1 period length, stop at 2 pi. So I got my function sine of theta. You would not use cosine of theta. Cosine of theta would be if it started up here at the top. If I started, right here, if that was my starting point, I'd start at 1, and then I would go down to 0, and then -1 back to 0. It would look something like that, okay? And that would be a cosine curve because I start right up there. Okay. So I'm going to get rid of all that. All right. So number 2, describe how your function in this graph would change if the windmill blade has a length of 3 meters. So it would kind of be like I still have the same angle, except now my height is still 0, but when I get up to the top up here, and it's a little off, I didn't leave myself enough room, this height is going to be 3 meters above. So basically it's going to be the same exact graph, but I'll tell you what, I'll copy this. Come down here. It's going to be the same graph. The only difference is it's going to go up to 3 and down to -3. So we'll still start at 0, but now we go up to 3 and down to -3 when it's at the top and bottom. Okay, so it ends up being kind of like a vertical stretch. Okay, so think of it like this here. We got, let me clear this here. So we got, here's my longer windmill. So at 0 radians, it is at a height of 0. When I swing it up here, my height is 3 at pi over 2. And then we get it to swing. Hang on a second here. Hang on, sorry, I've got a little bit of a smartboard problem here. Swing it around here. This is at height of 0. And then down here I'm at -3, and then I finish back at 0. Okay, so you can kind of see on my blue graph over here on the right that at 0 radians, we start at 0. Pi over 2, we're up to 3. Pi, we're at 0. 3 pi over 2, we're back down, or down at -3, and then we finish at 2. All right, so I need to multiply all the y's by 3, so I'm going to call that y equals 3 sine of theta. And if it had a length of 0.5 meters, it'd be y equals 0.5 sine of theta. So on here, still start at 0, but then you only go up to 1/2, back to 0, down to -1/2. So that would be what that one would look like. Let me write that in green so that you can see them on the graph. Okay, so those would be your 3 graphs there. So you're starting to see that your amplitude is controlled by the number in front of the graph, okay? And everything would work the same for a cosine curve too. Your amplitude would get bigger if the number in front of cosine theta is greater than 1, and your amplitude would get squished down. It'd be a vertical compression if your number is between 0 and 1, kind of like the green graph that we had there. Okay. So test your predictions using graphing technology. So what I did was I graphed them on Desmos there, and you can kind of tell that we were right. So this is y equals 0.5 sine of theta. The blue one was y equals 3 sine of theta, and then the red one was your parent function. It's just sine of theta with no stretch. Okay. Amplitude of each one of these, the amplitude of the blue graph is 3. Amplitude of the red is 1, and the amplitude of the green is 0.5, okay? And the midline of all of them is y equals 0. Okay, your midline just goes right through the middle. That's y equals 0. There you go. All right. Same situation, we got a windmill, radius 1 meter, and it's this time its center is 8 meters off the ground. So it's higher up, so it's not at the origin. It's kind of like this is my XY axis right there. Kind of like I have 8 meters. This distance from here to here is 8. Okay, so that's like centered at 0, 8, basically. All right, so let's read what it says. Point W starts at the tip of the blade in the position farthest to the right and rotates counterclockwise. Write a function describing the relationship between the height h of W in meters and the angle theta of rotation. So my height, I guess maybe on the last graph, I used Y. I probably should have used H, said use a height H. So I guess I probably, instead of Y, I probably should have used H. If you think about it. So I'll change them just to stay consistent, but basically it was like Y. All right, so here we go. Let's see what we can do. So still going to be a sine graph, but here's the difference. Our radius is actually 1. So my graph's a little disproportional here because I kind of didn't really have enough room. So maybe I should move that down a little further. Okay, so let's just say it'll look a little bit better. This distance here is 8 from here to here. So we don't need to change our amplitude, but at 0, our height is actually 8. So we're going to kind of need to add 8 to everything is what's going to end up happening. Because if you think about it here, your sine at 0 is 0, but the height is 8 units above, or 8 meters above. Now when my windmill rotates up here to the top, my angle is pi over 2. I'm now going to be at 9. So the sine of pi over 2 is 1, but then you got to add the 8. So what ends up happening is when my windmill gets moved above, it's kind of like a vertical translation. So that would be my function there. Okay, we would usually use Y instead of H, but that's what the problem says. Okay, so graph your function using technology. How does it compare to the graph where the center of the windmill is at 0, 0? So it should look like that. All right, let me clean this up here. Get rid of some of this stuff so you can see it. All right. So if you look here, it's the same graph, it just moved up. Okay, so at 0, we're at 8. At pi over 2, we're all the way up at the top, so we're at 9. At pi, we're back down to 8. Pi would be like right there, so the height would be 8. And then at 3 pi over 2, we're down here at the bottom, so it's 1 less, so we're at 7. And then 2 pi would be right back here, back up to 8. Okay, so there we go. How does it compare? I would say it looks like a vertical translation up 8 units. Okay. So if it was 11 meters off the ground, well, it'd be the same graph, h equals sine of theta, but we're going to have to add 11. So everything, the midline is basically going to move up 11. So it's pretty much the same graph. It's just, if I were to trace it and start translating it, okay, the original sine graph starts right there at 0, 0. And then if I translate it up 11, Goes right there. All right, now obviously my tracing was a little off, but you see how that works. It's just a vertical translation. Just add the number on. So my amplitude on this graph here is still 1, okay, because it's from the middle up to the top. That's a 1 unit. And my midline would be y equals 11. All right, so let's tie it all together here. So what is the midline of f? Explain how you know. So you're going to just take a look at the graph here, and you're going to kind of go right through the middle there, and that looks about right. So that looks like my midline is y equals -3. And how do you know? You could, one way that you could check the midline if you can't fully see it is you could measure the distance from the top to the bottom and then divide by 2. So basically this distance here from -1 to -5, that has a distance of 4. 4 divided by 2 is 2. So I could say, oh, I got to go down 2 from -1. So -1 minus 2 would give me the -3. Or you could go up 2 from -5. -5 plus 2 would give me -3. Either way, if you can't fully see it, like there's no grid on there, so it's a little bit harder, but there you go. Amplitude, obviously the amplitude is 2. Okay, that distance, we already kind of said that earlier. What if I wanted to figure out the equation of this thing? So we know our amplitude is 2. So I kind of look at it here. My period length is still 2 pi. It really kind of looks like a cosine curve because if I moved it up here, it would start at 1, but it's going to be bigger. It's going to be, my amplitude's greater. So I think I'm going to say y equals 2 cosine theta. And then I have to shift my midline down 3. So I'm going to say, looks like vertical stretch by 2, because my amplitude went from 1 normally on y equals cosine theta. It has an amplitude of 1 because there's a 1 in front of it. So vertical stretch by 2. I put the 2 in front, and then it's going to be a vertical translation down 3. That's because my midline on a normal cosine, y equals cosine theta would be right there at 0, and that's shifted down 3. Okay, so if I wanted to kind of graph y equals cosine theta, it would look like this without any transformations. Obviously, I need to get it stretched a little bit. You can see there, if I move it down 3, doesn't have the right amplitude, so I need to stretch it and move it down 3. Okay. All right, sketch a graph of the function given by 2 sine of theta. So my amplitude is going to be 2. Let's see. Add 0, sine is 0. I'm going to skip the pi over 4. I'll just go to pi over 2. Sine of pi over 2 is 1, but I got to multiply it by 2. Sine of pi is 0, times 2 is still 0. Sine of 3 pi over 2 is -1, but I times it by 2. And then 2 pi is still 0. Okay, so you can make a chart here if you want. Okay, and you can plug in 0, pi over 2, pi, 3 pi over 2. And you could take the sine and then times it by 2, but hopefully you're getting pretty good at this stuff. So this one is going to move up 3. So I'm going to just do this. I'm going to just move my midline up 3 right here. And I know that the sine curve starts at 0. Oops. Sine curve starts at 0. No, amplitude's 1 still, so at pi over 2, we just go up 1. So we go from 3 to 4. At pi, we're back to 0. 3 pi over 2, we go down 1, so we're at negative 2. I'm sorry, we're at 2. And then we finish at 2 pi, so there it goes. Okay. All right, so that's it for the lesson. Hopefully you guys are good with amplitude and midline.